Okay, again, congratulations. You've made it to the end of the course. This is lesson 34, geometry part 2. We're going to be looking at perimeter, area, volume, and surface area calculations. We will be using our calculators for this part of the course. So let's have some definitions. Two measures of plane figures that are very, very important as you're heading up through that math ladder, like I said, climbing that math ladder, is the distance around a plane figure, called the perimeter or the circumference, and the area of the plane figure. So the number of square units in the interior of a plane figure is called the area. So we'll be having a heavy focus on perimeter and area, and then we'll soon look at volume as well. Okay, let's begin simple and build a rectangle. And I will assume that you will devote these formulas to heart. If we come upon a formula that I don't want you to devote to memory, I'll let you know. But I want you to be able to compute the perimeter of a rectangle. So you can just memorize this formula, 2L plus 2W, or if you think about it, if perimeter is just the distance around the object, an easier way to say it is just add all sides. That's just an easier way to think about it. So let's take a look at this example. It says find the perimeter. Well, this is 8. Well, if it's a rectangle, then this side must also be 8 feet. And if this is 7, then this side must also be 7. And then if you're going to add all the sides to get the perimeter, then you're looking at 8 plus 7 plus 7. And that's where you see, or that's 2 8s plus 2 7s. So that's where you kind of see that 2 lengths plus 2 widths. But then we're looking at 16 plus 14, which clearly makes 30. But 30 what? What about the units? So feet. 30 feet. Okay, big note to self, perimeter is always measured in units, whatever the units are, feet, inches, yards. Okay, area, as we're going to see in a moment, would be units squared, and volume would be units cubed. But we'll hold that thought. Okay, so perimeter of your object, whatever your figure may be, really just means add up all the side lengths. Okay, let's try another on the next slide. Now with a square, you know that all sides are congruent, are equal. So you could memorize the formula 4 times the side length. Or you could just say, hey, I'm going to add up the 4 side lengths. So if you have to find the perimeter of a square that has a side length of 12, you could say 12 plus 12 plus 12 plus 12. Or you could say that's the same as 4 times 12. No matter what, you're still arriving at 48 centimeters for the perimeter of a square that has side length of 12. Okay? Hope that helps. Now let's try perimeter of a triangle. And again, all these you would be devoting to heart, these procedures. So the good news is with perimeter, you're not really memorizing a formula per se. You're just knowing that you're adding up all the side lengths. Speaking of, a triangle has 3 sides. So let's take a look. If this is 7, and if this is 9, and if this is 12, and by the way, I'm not going to get tricky. Notice the units are all feet. If the units were sort of mismatched, like feet and inches or yards, you'd have to do your conversions, but I'm not going to go into conversions right here at the tail end. So to get perimeter then for this one, we'll just do 12 plus 9 plus 7. So you've got 21 plus 7, which is 28. And there's where you see the answer, 28 feet. Okay, so if you're making a general rule, the perimeter of a polygon is the sum of the lengths of its sides. Okay, let's go to the next slide. Circumference of a circle. Now, obviously a circle doesn't have those hard edges, right? So circumference is the distance around the circle. So if I'm a little particle traveling all the way around the circle, how far did I travel? Well, that depends on the diameter of the circle. So what's really cool, and I put a little snippet here, a website, you can actually check out the history of pi, because they knew this even in ancient times, that the circumference divided by the diameter always results in the same ratio, pi. which is about 3.14. So I really encourage you to look into the history of pi, which is quite fascinating. But what I'm getting at is if they knew that circumference divided by diameter is always this same ratio pi, then you can manipulate the formula. See, you can cross multiply, say, and then say that c is equal to pi times diameter. So you can calculate the circumference then by simply taking pi, 3.14, times whatever the diameter of your circle is. Okay, so now you do want to devote this to heart. So we can memorize that circumference equals pi times diameter. Now, since diameter is twice the radius, then a different way of expressing that formula would be 2 pi r. Feel free to memorize either one of those forms. I like to pi d. I always say pi d. So let's dive into this example. Find the perimeter, or which means the circumference of this circle. Well, if I know from here to here is 8, then I know the whole way across is 16. So note to self, diameter is 16. So I can use the 2 pi r formula. Or I just want to note to self, I could use the pi d formula. Either way, I'm going to arrive at pi times 16, because even here, 2 times 8 is 16, and 16 times pi. Now, in terms of, you can use 3.14. I do want to show you this, though. A lot of calculators have the pi button on them. So I can hit 16 times 3.14 and get approximately 50.24. Or I do want to mention, if you're using the pi button, which is right here, times 16, you're going to get a slightly different answer, and that's because we had chopped off the decimal. So don't think you're crazy if you get a different answer when you use the pi button. It's taking the decimal expansion out. In fact, if you want to take a look at the expansion of pi, it's actually 3.141592654, etc. And it actually never terminates and never repeats. But for this course, it's perfectly fine if you use 3.14. Okay? So I do want to mention that, or use pi button. Okay, let's take a look at the next example. Now we're going to look at area. So when we start talking about area, we're looking at the interior space, like as if you were going to paint this plane figure or put an area rug on top of there, right? So I'm giving you this little cheat sheet, but I want you to memorize this and be comfortable applying these formulas in future courses. So we have a area, length times width of a rectangle, side times side for a square, 1/2 BH for a triangle, BH for a parallelogram, and a 1/2 small base plus big base times height for the trapezoid. Now you have this here in your notes that you've printed out on iTunes. What I'm going to do on the next slide is just dive right in and apply it. So you just want to be comfortable grabbing any of those situations at any time and applying those formulas. So here we go. Area is always measured in square units. When finding the area of a figure, check to make sure that all your measurements are the same units before you make your calculations. So here we're all in yards, okay? And I want to find the area of this figure. So first thing you do is you should grab the formula, 1/2 little b plus big B times the height. That's because it's a trapezoid. So I grab the formula and I start plugging and chugging. Okay, little b means little base. So your little base is this, 3. Big B is your big base, which is this base here, which is 5. You might be thinking, what's the height? The height of your trapezoid is, makes a 90 degree with its bases. So your height is 3, and then times 1/2. And all I have to do is crunch that out. I can do it on a calculator or in my head here. 3 plus 5 makes 8. Now, if you're just kind of moving left to right, 1/2 times 8, or half of 8, is 4. And 4 times 3 is then 12. But check out the units. You could say 12 yards squared or square yards. You could say it either way. So if you, I'm assuming you guys are comfortable with fractions now, but if you like, instead of saying a half times 8, you could say 0.5 times 8. You could literally key it all in and then times 3. But no matter what, I'm still arriving at 12. All right, I hope that helps. Let's go ahead and move to the next slide. Let's find the area of this figure. Now, style-wise, you may want to chop it. What I'm getting at is chop it into, rectangle 1 and rectangle 2. Okay, that's what I'm going to do. So, rectangle 1, to get the area of rectangle 1, I take its length times its width. Well, its length is 7, and its width is 12. Okay, now I'm going to take a look at rectangle 2. So you kind of chop it into the two different rectangles and then add their areas together. I'll do the now rectangle 2, I'm going to focus in on this rectangle here. And it's kind of like, what if I wanted this area, just this area right here? Well, then I'd have to know this width here, which I do, which is 5. But, this is big, I'd have to know from here all the way to here. And the thing is, it's not 19. So if it's not 19, what is it? Well, it's 19 less 7, so that's a little tricky. So it's whatever 19 minus 7 is, which is 12. So that is a visual thing. From here to here, whatever it is definitely not 19. In fact, it's 19 less 7. Because if you think about it, if you went the whole way across, it makes sense that it's 12 because 12 plus 7 would make the 19. So that's visual. That's kind of hard to train someone to do, but okay, so that's going to be 12. Now let's total everything up. So 7 times 12 is 84, and then rectangle 2, 12 times 5 is 60, but guess what? 84 plus 60 is going to make our grand total of 144. Notice the units, square miles. All right, hope that helped. And with this one, I have a summary of area and perimeter of various figures for you just to kind of have in your collection and make yourself comfortable. So we've discussed all these and we want to be comfortable getting the perimeter and the area of these various figures. I do have an example here. Find the area of the circle. Now, this means I don't necessarily want you to derive the formula, although it would be easy to sort of Google the history on that. But I want you to be able to grab the formula for area of a circle and retrieve it from your mind, after you have it memorized. So pi r squared, and fill in the blanks. So pi, we'll use 3.14 times your radius squared. Aha, but here I have the diameter. The diameter is 16. So the radius must be 8. From here to here, must be 8. So radius squared. After I fill in the blanks, then I type it out. 8 squared is 64, and then times by 3.14. So you're looking at, if I round it to the nearest whole number, approximately 201. So approximately 200.96. Square what? Centimeters. All right, so now we've had lots of practice with retrieving formulas. In fact, a lot of people tell me that they like this part of geometry because as long as you know the formula, you plug and chug everything into the right location, you got it. Okay, let's see if we have any more slides. Yes, we do. Volume and surface area. So I like to think of volume as like a fish tank. How much water can I put in the fish tank? Volume measures the number of cubic units that fill the space of a solid. The volume of a box or a can is the amount of space inside. volume can be used to describe the amount of juice in a pitcher or the amount of concrete needed to pour a foundation or the amount of water you need in your fish tank. All sorts of real-world applications. Once again, you want to devote these to heart. Okay, volume of a box, and I'm just going to kind of draw that. So if we have what's called a rectangular solid, here's how I would try to draw in three. Now we're living in 3 dimensions, right? Volume of a box is length times width times height, LWH. Length times width times height. Surface area of the box is 2LH plus 2WH plus 2LW. Now you could memorize that, or I'm going to show you a way to just kind of think about it logically here in a moment. All right. So this will be our final calculation for these notes, so let's go ahead. We have a rectangular box, and they're telling us, you may even want to hit pause and try it on your own first, but they're telling us that it's 3 by 1.2 by 2. So 3 by 1.2 by 2, length, width, height. Okay. If I want to get the volume, I have the answer snipped in, but if I want to get the volume, I'm just going to take length times width times height. So I would say volume is the easier of the 2 calculations. Let's key that in. So we're going to take 3 times 1.2 times 2, 7.2. So now we see where the 7.2 cubic feet came from. Okay, now surface area, that's the one that gets people sometimes. So if you're just a formula person and you want to plug and chug, we can do it that way. That's probably a safer way for these notes. In fact, I'm going to do it that way since we have the formula right in front of us. So it says 2LH, so we have everything labeled LWH. So let's just let's re-record that formula. 2LH plus 2WH plus 2LW. And then we can literally fill in the blanks. So 2 times your length, which is 3, times your height, which is 2, plus 2 times your width times your height, plus 2 times your length times your width. Whew. So after all that sweat equity, let's clean that up. 2 times 3 is 6, times 2 is 12, so I'm just kind of doing some mental math here. 2 times 1.2 times 2 is something, and 2 times 3 times 1.2 is something. Just kind of going to clean that up, do it in pieces. 2 times 1.2 times 2 is 4.8, and 2 times 3 times 1.2. Now remember, if we were forced to do this by hand, we could. I'm just using the calculator to alleviate. Okay, so 7.2. And now we can add that all together. So 7.2 plus 4.8 plus 12. And voila. We got 24, and I have the answer snipped here. Surface area is 24 square feet. Notice the units, square footage for area, cubic footage for volume. All right, and I was thinking about it, and that probably is your safest way to deal with surface area of a box, is just by grabbing this formula and basing it off of your drawing that you had labeled. Okay? Little side note, so the only formulas I make you memorize for this course is the volume and surface area of the box. I do have a list here of other volume formulas for other figures that would probably be important. I snipped it from the Martin Gay textbook, and these Aside from the box, like the sphere, the cylinder, and the cone, I would give those to you, and you would just have to apply them. But I just wanted you to have them there for your records. Okay? I believe that sums it up. Congratulations. Good job out there.